computer setup. And I recommend if you're pouring anything, doing anything with liquids, you step away from your computer or step away from your laptop, just for that safety, so you don't break any of your technology there. But today, our theme is polar molecules, emulsifiers. And there are two different kinds of molecules. We talked about electrons yesterday. There are polar molecules and non-polar molecules. So I will start out by giving you a demonstration here. I'm going to need to change my camera.
Well, let's hold off 1 second as people are still coming to get in our room. And I know we are all like really excited to get going. And you know, obviously, Mr. James is really excited too, because this is his wheelhouse. But first and foremost, with everybody who is in here, I want to make sure that everybody's got in here and is going to be ready to go with this, because we're really excited about science. There is one question here, a very good question.
Yes.
Ian wanted to know, what are molecules?
Molecules are the little tiny bits that make up everything. Everything you touch, everything you see is made up of these tiny particles called atoms, and atoms will work together to make molecules. So even the air around you is made up of atoms, and different atoms will make up different materials. And you can combine different atoms to make new materials. And those materials may be in the form of a molecule, where you have two or more atoms combined together. So that is a molecule.
Awesome. I think that everybody is in from the waiting room now, Mr. James. If you just want to give us your presentation name one more time, I think we'll be ready to go.
All right, so I'll actually just start with my screen share here. But today we're going to be looking at polar molecules and emulsifiers, all big words that we're going to go over. And somebody asked what a molecule is, and here I have a picture of it. So some molecules have what we call a positive end and a negative end. And these molecules are attracted to other polar molecules like a tiny magnet, because like we saw with static electricity yesterday, electrons are going to push away other electrons because they're negatively charged, and positively charged particles, known as protons, will attract those negatively charged ones. So if you have something that is like a tiny magnet that has a positive and a negative end, they'll be attracted to similar parts. So this is mostly determined by the distribution of electrons within a molecule. If you have all of your electrons bunched up on one end of a molecule, then it will have that polar effect. If the molecules are evenly distributed, it won't be polar. Basically, if a molecule is polar, it's going to have some attractive force, act like a little tiny magnet. So I had a example here. Let me go back to my camera. I'm going to be switching back and forth between my slides and my camera a lot today. All right, so I have here a bunch of Lego studs. We could say that these are like molecules. Specifically, these are polar molecules. I can kind of push them around, mix them about, but they're not really sticking to each other, not really doing anything. And then I have these magnets. These magnets act like polar molecules. So every time I throw in a polar molecule, you see it's not really attracted to the non-polar ones, but as I throw in more, the polar molecules are attracted to each other, and they just keep sticking and sticking. And I can keep throwing more and more polar molecules in here with my little tiny magnets, and they will all stick together more so than they do to the Lego studs. So this is similar to how water and oil works. Have you ever heard oil and water do not mix? Well, water is like your molecules that stick together because they're polar. And oil is non-polar. So it doesn't really want to stick to much of anything down here. That's going to be kind of the basis for most of our experiments today. So while I have this overhead camera, I have some real water, not just simulated water here. And I'm going to put it, oh my gosh, where did it go? I had some pepper I intended to use. I think I left it in my kitchen. Give me 2 seconds.
While Mr. James is running to get his pepper, keep in mind you can always type any of your questions in the chat box. And as we get a minute, we will share those with him. So be thinking of stuff that you are wanting to ask about as we go through, as Mr. James goes through the presentation.
Okay.
It's great to see you guys today. All right, thanks. It's all yours, Mr. James.
Sorry, I thought I had everything on my table. So I'm going to take some pepper here and sprinkle it on top. All right, so tell me in the chat here, what is going to happen when I touch the surface of the water?
Ripples. Dylan says ripples. Abby says it's going to separate. William and Isaac say it's going to stick. Another vote for ripples.
All right, so we'll have some ripples. You notice right now all the little pepper flakes are floating on top of the water. So I'm going to touch water and, yeah, some ripples. And now I have a wet finger with some pepper on it. But if I focus super, super hard, I can cause something else to happen. I'm going to use my mind to move the pepper flakes on the surface of the water. I'm going to do the same thing I just did. I'm just going to reach out and I'm going to touch it. Ready?
Somebody did guess that the pepper will move away. So maybe they're in your mind reading already.
Yes, just to show off my superior mental prowess. Now,
Oh, somebody's guessing, Mr. James, that maybe you put something on your finger.
oh, huh. So maybe my magic trick didn't go off completely. You're right. I put my finger in this dish soap before I touched it. And dish soap and soap in general is really great because it can get rid of things like oil, grease. If you have like fats or anything like dirty on your hands, you always want to wash your hands with a soap. And this is part of the reason why. When I touch soap into the water here, water has what we call surface tension because all those molecules are attracted to each other. Now I can go back to my, whoops, I can go back to my main camera here now. There we go. All those water molecules are attracted to each other, and especially on the surface, there's almost like this little thin layer where you can see the water like curved and bent. Have you ever done a belly flop in a pool?
Belly flap, yes. A couple
Couple
no's,
yeses.
but a lot of yeses.
I don't recommend it. It's painful because water has surface tension. So the water molecules at the top of water are holding together. And when you do a belly flop, it's like hitting the ground because you got to break that surface tension. You got to break those molecules apart. But when I touch this soap in here, we see that surface tension is broken by the soap because soap has this ability to connect to both polar and non-polar molecules like that. And that's why it's so great for washing your hands because it will attract both soap and oils. Because if you wash your hands with just water, you're not going to get any oil off your hands.
By the way, I know some people were planning to do this experiment with Mr. James. You should be able to turn your cameras on now. I know for a while you weren't able to turn your camera on, but if you wanted to turn your camera on to show Mr. James or Camp Counselor Becky what you're doing, you should be able to do that now. I just wanted to let everyone know.
Yeah, so now that I've shown off the magic, you can try that magic trick too, where if you have some, I just use basic pepper. If you have some, and you sprinkle it into a bowl, you can touch it with a bit of soap and you see all the pepper flakes move. I can give you a moment to try that before I move on.
By the way, not necessarily a thing about the experiment, but Carly says she loves your hair. So I just thought
I was just going to say that. Yeah. Vote
Thank
for
you.
Mr. James's
Just
hair.
as you did last night.
And by the way, I did see a question. You had mentioned something about belly flop, and a few people said they don't know what that means, and many people said they don't know how to swim. So just real quick, just a quick poll. How many people know how to swim? Put it in chat or raise your hand if you know how to swim. How many people know how to swim? Okay, Delilah, Micah. All right, you got a few people. A lot of people don't know how to swim. You're like me. I don't know how to swim either. I tried to teach myself on YouTube. It didn't work out well.
Well, even if you do know how to swim, I don't recommend trying to belly flop because it can be very painful. It's just like if something hits your chest, hits your stomach or belly really hard.
Aiden swam 60 million years ago. Keep on going, Aiden. Maybe this will be the summer that a lot of our friends like Nathaniel and Aaron pick up swimming. So
Good. If you can swim for exercise, it is one of the best exercises for you. I'm going to put this down somewhere. Hopefully my cat doesn't drink it.
hey, Mr. James, Aiden goes to the beach every week. Do you know, does this kind of experiment work with salt water or just tap water?
That is a good question. It should work with salt water too, because the salt in salt water is also a polar molecule, meaning that it's going to behave and be attracted to the water molecules in a similar way that other water molecules are. And the soap
A lot of people are typing salt water in here, so maybe I'm the one learning lessons today. So yay.
All right, and by the way, if you have a question, you just put it in chat. I see some people raising their hand, but it's okay. You just put it in chat, okay? We'll ask for you.
Yeah, I'm away from my desk, so I cannot see.
Yep, I think you are at a good spot to keep going if you are ready to move on.
Okay. So next up, I said if you had a small sealable container, I couldn't find a peanut butter jar, so I found this old test tube that I was using for cooking spices. So I'm going to use this. Next, we're going to make what I often see called as lava lamps. However, they do not glow up, so I call them lava shakers because you can shake them up. And by the way, one thing that I did not mention on my material list for today that's going to be really helpful is something like a turkey baster, something that can get liquids and then put them in somewhere else, because it's going to be messier if you're pouring. And I apologize if I mentioned that before.
Sorry, Abby wants to know, is it okay to use a jar for this one?
Yeah, I said jar or anything that is sealable. So I have a stopper I can just put on the top of this. If you have something like a jar, water bottle I see somebody holding up, perfectly fine.
Perfect.
And I also like this one too, because I don't have to pour as much in here for me. I'm going to start, especially since this one is tiny. I can't really. I'm going to start by pouring some water. But I'm not going to fill my container all the way up. So now I just have a container maybe about halfway filled with water.
Sorry to interrupt just a minute. Kenny, we are on the one where they're making lava lamps. I'm not quite sure if it was titled something different on Mr. James's experiment paper, but it's
called lava shakers.
Lava shakers. Thank you. This is
like
the one with the jar.
So now I have my container filled maybe about halfway with water. Now we've discussed how oil and water do not mix. So now I have some vegetable oil. I'm going to be very careful because I still have my keyboard and mouse here. I'm going to also take a little bit of vegetable oil and fill it up almost to the top.
Also, if you remember yesterday, I mentioned something about possibly having a funnel if you need that too. Now would be the time to use something like that too.
Oh yes, funnel would be a great one too. So now I have oil and water. And as you can see, they are not mixing. You can, don't shake it now, but if you were to shake this, it would mix a little bit, but then you'd see it separate again. So I have some oil and water in my container. Mine's just a lot tinier than many of yours.
So are you about half and half oil, half water?
Yeah, about half and half. If you have more than one of the other, that's fine. The exact proportions don't really matter.
Cool.
Now I'm going to take some food color. Choose your favorite color. My favorite color is red. Goes with my hair. And I want you, and this is why I said to use a clear container if you have it, because you can see what happens. Watch very carefully when you put a single drop of food coloring into the oil. I'll give you a chance to try it yourself first before I show it off.
How many drops do we add? Abby asked.
I'd say maybe 1 to 5.
Okay.
But add them one by one. Don't just squirt it in.
No.
And watch
Anne's
what
favorite
happens.
color is red, and Gideon says his is sitting on the oil. His food coloring.
I might have to give it a little tap and a shake, but here I see my drop of food coloring has kind of formed this little bubble. It's kind of stuck in. The food coloring mixes with water. It does not mix with oil. So as much as I try to shake it around and tap it to try and get it to mix with the oil, the food coloring will not mix with the oil. Now I'll add another drop. You can see. Go down. And if I want to get the food coloring to actually mix, my container does not seal super well. We're going to have to shake it a little bit to get the food coloring mixed with the water.
Yes, 1 to 5 drops of food coloring in your oil and water mixture. See what happens. And then it looks like Mr. James just shook it up so that it mixes with the oil and the water.
So now my oil's mixed a little bit in with the water, but we're going to see that separate if we just leave it be. And this could be like a nice little toy you have where you can go and I can't tilt mine because mine lid's not sealing properly here. But this can be a nice little demonstration where you can just kind of move it and watch the oil and the water interact with little waves there. I'm going to have to dump this out because I can't leave this be non-upright. But ask any questions in the chat. I need to go to a sink. And I'll wait for you to finish experimenting with that.
So it was water and vegetable oil. People are asking what type of oil, just regular vegetable oil. And then 1 to 5 drops of food coloring. A lot of people like red, just like you do, Mr. James. That seems to be a pretty popular color.
Personal favorite color.
Looks like Kenny's got his that he's showing us on his video. I'm just scrolling through to see if there's anybody else. Looks like Kenny's is kind of blue. Tristan and Grayson. Looking good. Charlie's got some red going on. Gideon. These are pretty cool. You guys, I am really enjoying this.
If you shook yours up a lot, you're going to have to let it sit, and you will see the water and the oil separate over time. It may take somewhere between 10 to 20 minutes, depending on how much you have shaken up in there. But once it's shaken and separated apart, if you slowly move it, you'll see the water and the oil slowly move about. Because again, like our magnets here, water is going to be attracted to water more than it is oil. And oil is lighter than water, so it's going to float on top, be separate. Many people say that water repels oil, and that's not entirely true. Water just wants to be near water more than it wants to be near oil. And if you have a mess, or if you spilled anything, you can take a moment. I should have said come with some paper towels too, because I imagine some spills will be inevitable. But let me know when you are ready to continue on.
Let me scroll through the chat for just a minute, make sure we are caught up. Looks like people are getting theirs completed.
Oh, and someone had a question. So, and it's interesting because we used to do a lava lamp experiment where we used Alka-Seltzer. And I know why we used Alka-Seltzer. We're not using it here. But Mr. James, I thought you would like to approach that as to why we're not using Alka-Seltzer in this particular experiment.
Why we're not? Because I didn't think of it. But if you have Alka-Seltzer, put some in there. That'd be cool.
So do you want to explain what Alka-Seltzer does when you put it in there?
Well, Alka-Seltzer reacts with water to produce gas. It's carbon dioxide. And just like if you blow bubbles under water, that gas is going to rise up. So you'll see that gas, you'll see the Alka-Seltzer slowly move through your layer of oil, no reaction. But then once it touches water, it will start reacting and bubbling, and those bubbles will go up through all your layers. It'll look kind of like a little lava lamp too. So
with the lava lamp, the idea is that the heat creates some sort of reaction to make the bubbles move. When you drop an Alka-Seltzer, it's not the same kind of reaction, but they move way more rapidly. And you have that kind of idea where basically the food coloring, which is water-based, is trying to move through the oil, and the oil's going, I don't like you, go back and hang out with the water. And it's going back and forth with each other. Kind of like when, you know, your parents make you hang out with your little brother or sister and you just want to keep kicking them out of the room and then they keep coming back. It's kind of the same deal. But it's a very good question. Abby asked that question about why we didn't use Alka-Seltzer, and I just wanted to make sure that we approached that because I know that was one of our favorites that we used to do with the Franklin Institute a few years ago. And, you know, as a reminder, we'll be at the Franklin Institute this Friday too. So.
Yes.
That's pretty cool. These questions are awesome. I'm learning a lot. I was just telling Camp Counselor Chic that I didn't know you could do Alka-Seltzer for something like this. So
yeah,
it's a good day to be here, Mr. James.
Food coloring, because you see the food coloring move through the oil without breaking, and then once it gets to the water, it'll mix in with the water. But you can only do it once. You gotta see that. Are we ready to move on to our next activity?
We are. People were just commenting a couple times that they noticed your cat is ginger, a lot like you are. So a lot of red going on today.
I've been fighting to keep him out of here. I unironically used the phrase, Dexter, get out of my laboratory this morning.
Hey, Declan had a question. Would Polident work like Alka-Seltzer does?
Polident, what is that?
That's the stuff that you drop in. I know it as the stuff that my grandfather used to drop in to clean his dentures.
Oh, yeah.
As like a foaming sort of thing.
Gas that reacts with water, probably, yeah.
Good questions. So, yep.
For this next activity, I had listed a lot of different materials, mostly liquids. So just to go through them, I have honey. This bowl, I have corn syrup. I have milk, fish soap, water, vegetable oil, and some rubbing out.
Mr. James, do you want us to be able to see your bowls? If so, can you angle your camera down just a little? If we don't need to see them, that's perfectly fine.
I cannot angle this camera down, but I have this
Okay.
camera that can show a top-down view. If you want me to
Okay.
do it.
We can see the very edge of the bowls that's closest to you. So if we need to see something happening in the bowls, you might want to move them.
Now,
As
I'm
needed.
going to be doing everything in here, and
Perfect.
it's going to be best viewed from the side, so I'm going to hold it up.
Okay, awesome.
All right, and this is where I'm going to quick go into describing what density is.
Abby asked, did we need whole milk as well for this?
Whole milk is preferable because whole milk has fat in it. So whole milk is going to work better. All right, so density is a measure of how heavy an object is relative to how much space it takes up. Every molecule has its own mass, but some molecules are heavier than others. So a classic question is, what weighs more, a pound of bricks or a pound of feathers?
Anybody have answers in chat? What weighs more, a pound of brick or feathers? Jovi says bricks. A couple people are saying neither. Somebody said feather. Dylan said feather. Wafik said neither. Miguel and Alejandro said trick question.
It is a trick question because they both weigh 1 pound. But if you can imagine it, a pound of feathers is probably going to take up a lot more space than a pound of brick will probably be kind of tiny, because brick is more dense than feathers. And everything has its own density. And in a liquid, the heaviest molecules are going to be pulled to the bottom, while the lighter ones are going to float up top. What's also important is density is independent of weight. And by that, I mean, you can have some materials heavier than others, but weight is a combination of how dense that material is and how much you have. I could give you a pound of bricks, and then I could give you another pound of bricks, and then you have 2 pounds of bricks. But I cannot change the density of that brick. Does that make sense? And there's a famous story I encourage you to look up from Archimedes. That's a little silly, but he came up with this principle, and it says for an object to float, the mass of the water, I had a spelling error there, the mass of water it displaces must be greater than the mass of the object. So I want you guys to think here, and I'll wait till I get a response in the chat, because I know I'm going fast here. Does steel float?
Does steel float? Let's see what our friends have for answers. I'm seeing a lot of no's. Abby, Gabriella, Daniel, Nico says no. Akira says it can. Zayana says no. Danielle says yes.
It's
a lot more
interesting that
no's, a couple yeses coming in.
it's interesting that I'm getting a lot of no's, because I have on my screen right here a boat that is made out of steel. So clearly,
Gideon just typed yes, the boat is made of steel, and Wafik says according to the law it can.
yes, and the way boats work is that they are hollowed out. So boats are designed and shaped in such a way that they push out water with their shape. There's a lot of empty space inside of them. So if a boat was entirely like a single block of steel, it would sink straight down. But that is not. They have a lot of empty space inside of them, and that makes boats able to float. So that is the ability of density. So let's get into, I don't know if I should show my directions or just demo it, because I think I can only show like one at a time. But if you need me to switch back to my camera, I will do that. Actually, I might just switch back to my camera and I can switch back to my directions later.
Sure.
So first thing I'm going to do, I'm going to take a large tall glass. Yours doesn't have to be this large. I just like for everyone to be able to see it. If you use a smaller container or a smaller glass, you don't have to ultimately waste and dump out as many materials. We're going to start with the least dense materials and work our way up. If we do this correctly, we should get several distinct layers of liquid. So I'm going to start with honey.
Sorry to interrupt you. Abby wants to know, can we use a plastic cup?
Yeah, as long as you can
Okay.
see through it.
Okay, perfect.
When you pour the honey, make sure it does not touch the sides of your cup or container. So I'm going to pour my honey straight in, because if it touches the sides, it can affect the rest. And I'm just going to pour in so you can see it in a nice distinct layer. Honey is very good for you if you have a sore throat, by the way. Great with tea. All right.
Rafiq says, so basically you're going to layer different things. Is that where we're headed?
We are going to layer different liquids. That is what we are going to do.
Okay, perfect.
It's going to look really cool once we're done. Be proud. And this is why I said yesterday, if you're missing one of these ingredients, I don't want anyone to feel like they had to rush out to the store to get like whole milk if they had skim milk. You can probably just skip it. You just have one less layer. One thing I forgot to mention before we continue on to the rest of our ingredients is I actually added some food coloring to my corn syrup. I'm going to add some food coloring to my water. I've done my water red here. And some food coloring to my alcohol. And I already did that, but I should have told you guys to do that before we begin. So dye them 3 different colors because we like to make this look very colorful.
So the alcohol is one color, the corn syrup is another, and the water is a third color. Is that correct?
Yep.
Okay.
Just so you can tell them apart. I can give you a moment to do that before I move on.
Abby, we have not yet added anything after the honey. We are giving people a chance to add food coloring to their water, their corn syrup, and their alcohol, 3 different colors.
And you're going to want to stir the food coloring in before you add it, because once you add it, you can't mix it.
I think we're good to go. No questions right now.
Okay. So right now, if you just had food coloring mixed in with your corn syrup, you are ready for the next step. So this is where the turkey baster, if you have one, or a funnel is going to really come in handy. So I'm going to absorb my food coloring. I dyed it purple. And this is for syrup. This is also where you would add maple syrup if you have some too. So you might be adding that instead, but I have corn syrup, not maple syrup. Syrup is very slow. Okay. Now I'm going to very carefully add and layer corn syrup on top of my honey layer.
So we have honey in there. Next layer is syrup. And Dylan was asking if we can make it dark purple. You can add food coloring, Dylan, in whatever color that you would like. Mr. James picked his color. You are welcome to add whatever color you would like to see.
Yeah, add whatever colors you like for them. I tried to make them different colors. I know my vegetable oil is yellow and my dish soap is blue, so I tried to do colors other than that. All right, and I'm going to add a little bit more here. I probably won't be able to get this whole thing in here.
Carly, yes, this is being recorded and will be posted on YouTube as far as I know. Camp Counselor Sheik, if I am wrong, please correct me.
You are correct. And Akira is just asked for a little bit more time, and we're just taking our time. You can catch up. We're not going to move too quickly. If you need us to go over anything again before we go on to our next step, just let us know. That's for everybody in the room. You want to make sure that if you're doing this, you're able to follow along, okay?
Yeah, please let me know if I'm going too fast.
Gideon, we have not added anything after the corn syrup yet. We have honey and syrup in the cup so far.
And I probably good on my, I get the last bit out there. Probably good on my corn syrup there. So I'll set the rest of that aside. Right now I have a purple layer and a yellow layer for honey.
Declan, honey is on the bottom. Corn syrup or your regular maple syrup that you use for pancakes, that would be the next layer. Elizabeth asks if we're doing heaviest to lightest ingredients.
We are, or densest to least dense. So the next least dense material would actually be milk is coming up next. And I'll give people a chance to finish adding their corn syrup before I move to milk. Let me know when you're ready to go on. Do we have like a check or X system in Zoom?
I'm
not entirely sure.
Okay, that's fine.
Yeah, we can't necessarily do this to check system like you normally would in the other programs.
All right, that's fine. Let me know if you need more time in the chat.
Yeah, Andrew mentioned that we might be going too fast. Some other people said they're ready. Andrew, let us know when you're ready, and a few other people, let us know if you're ready. And Emery, you're right. We could open a Zoom poll. So if you want to have a poll that we go with Mr. James that says, oh, is everybody ready? And they check off, we could do that. I think chat might work a little bit better, but that is an option. Everybody's teaching us today. I like it.
Yeah. I'm not really familiar with Zoom.
Abby asked about the red glass. I believe that's your glass of water that you added food coloring to.
Yes, this is just water that I put red food coloring into. Nothing special.
So it looks like everyone is telling us that they're ready to go on because they're telling us different features of Zoom that we are learning as well. So
next, I have my tiny little bowl of milk. I'm also going to use my turkey baster. I'm going to fill this with milk. A lot more there. Milk's easier to pour that.
Now, so far, what have we added? What was the first thing we added?
First, we added some honey. And you don't want to touch the sides of the container as you add it, because it can mess with things. And then we added some corn syrup that I dyed purple, because corn syrup is actually pretty colorless. You can also pour maple syrup in there. We'll have this.
Gideon asks if cream will work instead of milk.
Yeah, if you have something like heavy cream, that will work very well. Now I'm going to carefully squeeze in the milk on the top layer here. You want to do it very slowly, because if you do it quickly, then it could mix your layers. And we're just trying to do all of this in a way that our layers do not mix.
Mr. James, can I ask a question?
Yes.
You keep talking about not hitting the side of the glass. Can you tell me why that is?
Because it essentially creates a pathway for some of the layers to go down and mix.
To mix. Okay, that's
So
what I thought, but I wasn't sure.
There's some of these layers are separated by oil and water, and some of them are just separated by density. But if there's something like a trail of honey or corn syrup along the side of your dish, and then some of the water that we put on the top layer that's separated by oil is going to be able to just trickle down through the syrup.
Okay.
So
Camp
it's the
Counselor
same-
Chic, I think I'm learning maybe more than the kids are today.
also kind
And
of the same
also, if you
reaction.
dyed your corn syrup, you're going to have a big purple streak along the side. It's probably more the reason why.
If you go into the idea of what we were doing previously with this, with water tension and ripples and things like that, sometimes things can mix, much like how you kind of mix with a belly flop there. If you had some stuff on you when you belly flop, let's say some sand from a beach, it would mix into the water, even though obviously they're different densities. And
Yes.
interesting thing about what you're doing, Mr. James, because a lot of times you might see chefs, they'll pour a liquid onto a spoon or something to get a streak or something like that. That's why we're being very careful not to hit those sides as well.
Yeah. So you see, I have 3 distinct layers right now. If you don't have distinct layers, then that is fine. I tried this last night. I had 2 or 3 of my layers mixed together, and I'm just trying not to do it like that this time.
And I think Wafik had asked if water is going to be on top, and I think you answered that sort of in your explanation as we were talking.
Yes, I have these laid out in order. So next up, I'm going to put in dish soap. Are you guys ready to move on to the next layer?
It looks like it. I haven't seen anybody typing that they need more time.
Yeah, I'll give it a moment to be sure. So very similarly, I'm going to use a pipette to get straight down the middle. I'm not worried about cross-contamination here. I'm just using the same pipette for everything. I still have some of my corn syrup in the pipette. All right. I'm going to very carefully squeeze this in here.
Mr. James, can you move your glass of water out of the way just a little bit? Thank you. That's perfect.
So the dish soap is a little lighter than the milk. And then that will be able to stay separated on that layer. By the way, you don't have to use as much of the ingredient as I am. I'm just using it a lot so that it's clearly visible from the distance that I'm back at.
I'm scrolling through the videos while you're adding your dish soap, and I'm seeing a lot of people hard at work. It's pretty cool to see what everyone is creating. So be sure you hold them up for in front of your camera so that we can see them as you're getting all of the layers added.
All right, so right now I have 4 distinct layers.
By the way, I must say, Tristan and Grayson, that is the biggest bottle of dish soap I've ever seen. But
Yeah.
it looks great. You guys are doing an awesome job. I see a lot of you who are doing this activity. That's great. And if you weren't able to do this activity now, we will be able to do it, have it on YouTube, so that way you guys can do it later on.
I have a lot of fun with this
slides
one.
with directions too that I can share. All right, so I have my dish soap added in. I see some people on camera adding their dish soap. Let me know when you're ready to move on.
It looks like everybody is ready to move on. If someone else needs more time, just put in chat.
For our next one, I have, let me squeeze out some of the dish soap here. The next one I have just water. So I just put in some red food coloring in. The red food coloring doesn't do anything. It just makes it so that it's like really cool to look at when we have this kind of rainbow colors at the end here.
Nathaniel, he's using something called a turkey baster, which parents will use for cooking sometimes. So he's able to suction a little bit of liquid out of each container. Then he's putting it into the glass right on top of the previous liquid so that it's not touching the sides at all.
Now,
and that's how he's creating the layered effect.
Now I told you guys for all of these ones going forward not to have it touch the sides as you put it in. Now I'm going to change that. For the water, as we get a little delicate here, gently squirt it down the side of your container. It's going to get a little sensitive now. And if you're very violent, it'll mix together. We want to be as gentle as possible. Turkey basters mixing it a little bit for me because it's a very large item. And you can see I have my milk and my water got mixed in a little bit together. But that's all right. You still see kind of a pink layer. And this is where it gets a little bit tricky. So you might see some of your layers blend, like I had mine blend, but that's all right.
Looks like some people are hard at work adding the water layer.
Add that one very, very carefully down the side of your container.
How's it going there, Nate? Are you getting a good layer of colors?
Looks like he's doing well.
Miguel and Alejandro. Oh, that looks good, Nate. That looks really good. Awesome, guys.
Good. If you have it done correctly, then your milk and your water won't have combined like mine. But if you do mix two layers, then that's all right.
By the way, guys, you know we're going to go to break in a little bit. If you need more time, you can work during the break too to finish this up. No problem with that.
Yeah.
Yes,
All
Miguel
right.
and Alejandro, the whipping cream is fine.
We got two more parts to add in. I just checked my time. We have about 10 minutes. Next, I'm going to move on, is vegetable oil. Vegetable oil is yellow, so it's going to be a pretty easy layer to see in here.
Wait a minute. So water isn't the top layer? Is that what you're saying?
No, water. It was dish soap and then water and then vegetable oil. So the vegetable oil is going to go on top of the water.
Abby, you can always start another container or make a second one during the break if you want to, but be sure to snap a picture of what you have currently.
All right. My turkey baster is a little large and clumsy, so it's mixing it. But you see here, I have a distinct layer of oil at the very top now.
Andrew, it looks like you're paying attention and adding more layers to your container. How's it going over there? Awesome, good. Just scrolling through and looking at some of these projects. Tristan and Grayson, that looks awesome.
And for my final layer, I'm going to add rubbing alcohol. I put in some colors to make this one look green. This one you got to put in very gently along the sides here too. A little bit of a mess, but that's all right because science is messy. All right. So mine, I had my water and milk mixed a little bit, but you see here I have mostly distinct layers: honey, syrup, milk, dish soap, water, corn syrup, and alcohol. Now I can do one more thing with this before we go. Everything in the way here. All right. Not only can liquids float on each other, but depending on the density of an object, those objects might float on different layers. So I have a couple of random objects here that I gathered, and you can find anything that is disposable or washable. You're willing to drop it in, and you might find like this piece of carrot here. If you can see it, they float on different layers. I'm going to try and drop in a screw next. And my screw is metal, sinks all the way down to the bottom. Let's try a paper clip. And it looks like my paper clip is sinking down to the honey layer, although a little slower. All right, here is a toothpick. My toothpick floats at the very top. My carrot's not at the very bottom. My carrot is somewhere in the middle. I think it's on the milk, because it's hard to see where that carrot is. I have a piece of a crayon, and the crayon is floating, looks like between the water and vegetable oil. And then this here is a piece of cheese I got from my fridge. And I know I've lost the cheese. Some of these are so hard to see because you get all the colors and the layers. But if you want to experiment, see what objects will float on what layers, because some objects will float at the very top, like the toothpick. Some will sink to the very bottom, like the screw. And some will float in between, like the carrot and the piece of cheese and the crayon. I don't see it. I assume it's somewhere in the milk water layer. So sorry if I rushed a little bit at the end there, but if you missed anything, here's the screen of directions that I had and the order to add them in. Does anybody have any questions?
We shouldn't stir it all together. You can try to mix it, but then you just end up with a bunch of goop. So I don't know if that would be a good thing to do.
Right. So ultimately, to get rid of this, you can just pour the whole thing down the drain. But if you want to mix it, you can. Just know that it will not unmix. It's not like the oil and water shakers that you have. A lot of these materials will mix together.
Oh, you Gideon did this in a Flyers glass. That looks good.
That looks great.
Yeah, I can grab my glass, bring it a little closer to my camera here. You can see my layers. Also, don't drink this because there's soap in it.
There's soap in there. No one wants to drink soap. That's not cool. It doesn't taste good. It's not good for you. Don't do that.
Not that I thought anybody would, but I just have to say it because I've seen some things.
Akira is working on their experiment, and it looks really cool. Very definite layers in there. Tristan and Grayson, looks great. You guys are doing fantastic with these. I'm just scrolling through the videos and see what I can see.
Nice. Right. Even if you have two layers that mix together, you can still continue on because you'll just have two layers that are mixed, but you can probably get the next few layers separated. The key
that
is
looks
just do
good.
it very, very slowly when you pour it in or squeeze it in with a baster or a funnel.
So someone asked, could you use the mixture for anything? And, you know, if you, or would you just throw it away? I don't know if you necessarily would use it for anything, but go ahead.
No uses other than it just looks really cool. And I know I'm gonna have to pour this down the drain, but I kind of don't want to do it right away because it's kind of neat to look at.
And remember, you don't want to keep it too long because there is milk in there.
Milk.
What happens when you leave milk out for a while? Does anybody know? No one knows what happens if you leave milk out too long? It spoils.
Spoils, yep.
And how do I know? Because I have left milk out too long. And let me tell you, once again, it's worse than soup. If you were going to try to drink that, it goes very bad and it's cold.
Not pleasant.
Mr. James, is there anything you want to add before we go to break?
Where did my mouse go? I was just gonna here. I'll just use my keyboard. I was just gonna say for tomorrow. There we go. For tomorrow, we have our rocks and fossils activities. So for that, we are going to be making something that kind of resembles bread dough. Where'd my mouse go? Kind of resembles bread dough. So it'll just be flour, water, and salt. So make sure you have that on hand because we are going to be making fossils. I'll show you some of the interesting rocks and minerals that I have in my personal collection. And I will have you guys be making crystals. So I said for the crystal options, you could have either two options I've seen. You can have, I said sugar is what I probably recommend to most people because you get to eat it afterwards. It's rock candy. It's just crystals. But then you could also use borax is what I will be using for my demonstration, which is not edible, but it does have a lot larger crystals that form as a result of it. So I'll be using that for the sake of like showing off on camera. And you can also use salt. It's just not as fun to eat, but it's something that most people probably have.
That sounds great. I think we're about ready to take a break for about 10 minutes before we come back to the butter experiment, shaking up butter with Mrs. Borelli. So if you guys want to take a break, grab a snack, grab a drink of water, and then we'll get started back with Mrs. Borelli in just a couple minutes.
Yep, and we don't need to leave here. So
yes, stay logged in.
Yeah, Mr. James, you can leave this up. I will ask a few things. Please don't post links in chat. I don't know what the links are. I know some people are excited because they have their own YouTube channel or they've seen this experiment somewhere and stuff, and that's great. But please don't post links in chat. However, you've seen what we needed for tomorrow's experiment. I'm going to be sending that out in an email as well. Hopefully, everybody got an email with everything that you needed for the whole week. But you will get that in an email as well if you need a reminder. And any of your parents or any of you can email me if you need to know what you'll need for tomorrow as well. Not to mention tomorrow for all our friends who's out there near the Pittsburgh area, if you're near Pittsburgh, if you're in Washington, if you're in Monroeville, all of you out there, we will be at the Carnegie Museum tomorrow. And for the rest of you, we're going to be broadcasting live tomorrow for the Carnegie Museum as well, so you don't have to be there in order to see what we're going to be doing, as we're going to be taking tours of various dinosaurs and all their bones and things like that. Is going to be cool as well. But you know what we normally do here. Hopefully you had all your liquids away from your computer. Get them away or get yourself away because it's stretch time. So hopefully you all remember what we do when we stretch. You want to put your hands up. Everybody put your hands up. Put your hands up. And you want to wiggle them around. Wiggle around. Wiggle around. And then you make a T. Make a T. And then you want to make a funny sound. All right, one more time. One more time. Put your hands up. Stretch them up. And then you want to wiggle around. You wave side to side if you want to. And then you want to make a T. All right, hold on. Let's make an O. All right. Now we go back, make a T. All right, stretch it out and make a funny sound. Bleh.